I have to say 3. Go. Wow! Look at Daniela doing cartwheels. This shows that she's in motion because there is a swing set as a reference point.
Let's watch Daniela and Vanessa have a race, and after we'll calculate their speed.
Oh! And dangerous. If you're one of us, then roll with us, cause we make the hipster.
I win! But I lost.
But who had the greater speed?
How do we calculate speed? Well, speed equals distance divided by time. So, Vanessa and Danielle were both running in this video. So, we need to calculate both of their speeds. So, Danielle and Vanessa. Distance between the tree and the trampoline were 12 meters. And their times were calculated by Daniela and Julia on their cell phones. So, their times were, Danielle's time was 6 seconds, and Vanessa's time was 4 seconds. So when you divide this, 12 divided by 6 is 2, and meters divided by second is meters per second. For Vanessa's time, it's 12 meters divided by 4 seconds equals 3 meters divided by seconds is meters per second. To answer Julia's question before, Vanessa had the greater speed because she went 3 meters in 1 second, where Danielle went 2 meters in 1 second. And we all know 3 is greater than 2.
Carly just found Vanessa and Danielle's speed. Danielle's speed was 2 meters per second, and Vanessa's speed was 3 meters per second. If you add a direction, you get velocity. They were both running east, so Danielle's velocity is 2 meters per second east, and Vanessa's velocity is 3 meters per second east.
Now we're going to watch Julia jumping on the trampoline.
Hipsters fall in love when we got our hot pants on and up. And yes, of course we does. We run in this town just like a club. And no, you don't want to mess with us.
There, Julia had the most gravitational potential energy because she was in the air and gravity was about to pull her down so she could do her next jump.
Jesus on my necklace. Got that glitter on.
In this picture, Julia squatted down because she just finished her jump. Now she has a lot of elastic potential energy. And she has this type of energy because she's pulling on the springs that are under the trampoline. Here's a picture of the trampoline springs.
On my eyes, stockings ripped off.
We're going to watch Danielle do a flip on the trampoline. In that video, Danielle had a lot of kinetic energy. Now let's find out how she got it.
Up the side, looking sick and
Plants use the sun rays, which is light energy, to perform photosynthesis. This produces glucose, which gives it energy to make tomatoes, which makes chemical potential energy. The tomatoes are used for the pizza sauce, which Danielle ate. This gives Danielle chemical potential energy to do her flip.
so let's go. Let's go.
Wow, that pizza made me really thirsty. Vanessa, can you fetch me a bucket of water?
Okay.
Thank you, Vanessa.
Wasn't that centripetal acceleration?
Okay. Now Carly's going to have her eyes closed and she's going to crawl across the floor. We have to tell her whether to go right and left and how long. This is going to show velocity because velocity is a speed with a direction.
Carly's obstacle course. And that's the prize.
Carly, move forward a 0.5 meter per second north. Stop. That was your velocity because it's speed with a direction, and you're moving at half a meter with the direction of north. Now turn to the left. Stop. That was acceleration because you accelerated. You changed your direction. Now turn to the right and go to your prize.
Come to the Johnny Depp. Come to the Johnny Depp.
Stop.
Stop.
Carly, you sped up. That was more acceleration. Now you can see your prize. Yay! Now Julia has potential energy because she has the potential to swing forward.
Kinetic.
Potential.
Kinetic.
Potential.
So, Julia, do you understand about kinetic and potential energy now?
I understand both of them, but what's friction?
It can't move.
Vanessa, do you know why Daniela wasn't able to slide on the carpet and was able to slide on the wood?
Because of friction.
Calculate Carly's acceleration. At first, when she was crawling at a velocity of half a meter per second north. And then she sped up to get to the prize. Her final velocity was 2 meters per second north. To find acceleration, we do the final velocity, subtract the starting velocity, and divide by time. Final, subtract start, divide by time. Carly's final velocity was 2 meters per second north. And we subtract that from her time, her starting velocity, which was half a meter per second north. We divide this by the time, which was half a second. 2 meters per second minus 1 meter per second, 1/2 a meter per second, is 1.5 meters per second. Divided by half a second is 3 meters per second squared. This is Carly's acceleration. Say 3.
Whoa, whoa!
Go forward.
Get down!
Climb forward. She's gonna look small.
And
Shut up!
stop.
Speed.
Or my hair fell into the video.
No.
Equals distance. What?
Do S equals.
No, it's fine.
It doesn't matter.
S is
Of course.
Thank you, Vanessa.
Wasn't that to give out accelerate?
Here you go. Can I go? Okay, stop. Really, stop.
Yeah,
I know how to
now we let ice cream.
My crouton! You knocked over my crouton!
I'll just wear these.
This is Mr. Hippo. Pill pack.
No.